Hello everyone and welcome back. My name is Mr. Cobalt, and in this video I'm going to continue to go over polarity of bonds and molecules. But here I'm going to give you a flow chart that's going to help you figure out whether or not a molecule is polar or nonpolar. So here's a few questions you want to ask yourself when you're looking at a molecule. Remember, you're going to need to draw the Lewis dot structure. You're going to have to know how many bonding pairs and how many lone pairs of electrons are around your central atom in order to figure out the shape of the molecule. If you can't figure out the shape of the molecule, then you can't figure out if it's going to be polar or not. Excuse me. So let's get into this. So the first question you want to ask yourself are ions present? Notice that the whole time in the last couple of videos that I've shared with you, that I didn't talk about ions at all. That's because when we're talking about polarity, we're talking most of the time, usually, or not, if not all the time, we're talking about molecules and non-ionic substances. So to talk about polarity in an ionic substance kind of is not, the same thing, is because we're talking about fully charged elements or ions in your compound, and so they form a crystal. And so, of course, there's going to be polarity in the ions because they have different charges on them. So when we're talking about polarity and polarity of bonds, we're talking about molecules. So if there are ions present, then it's an ionic compound, and the discussion of polarity doesn't really fit. Okay, so that's the first question. If yes, then it's an ionic compound, and we don't need to talk about whether there's polarity in the bonds. So if no, then you go to the next question. Are there more than two atoms in the molecule? So if not, then you would have to ask the further question. Are both atoms the same element? If they're not, then it's polar. And here's an example, right? So you have two atoms bonded together, they're different. Chlorine is much more electronegative than um, the hydrogen. It's going to pull the electron density more towards it. Therefore, it's going to have a partial negative charge. Remember, electrons are negative. So if the one atom is pulling those electrons more, then it's going to have a partial negative charge on that atom. And then the electrons are being pulled away from the other atom. So that's going to be a partial positive charge. So again, the polarity is going towards the dipole moment arrow is going towards the chlorine, and then that's going to be a partial negative, partial positive. If the elements are both the same, then it's a nonpolar molecule. So here we have the same elements, and the reason it's the same is because the electronegativity of the atoms is the same because they're identical atoms. So of course they're going to have the same electronegativity, and so therefore they're going to be pulling equally on those electrons. So there's an equal sharing of the electrons. So this would be nonpolar. And here we have two examples that we saw in my previous videos. One thing I do want to say about having different atoms bonded together, some atoms, their electronegativity are going to be so close together that the difference in electronegativity is going to be so small, and that we saw that with the carbon-hydrogen bond. But normally, you're not going to have a single carbon-hydrogen bond going on here. That's going to be part of a bigger molecule. So that brings us to our other part of our flow chart here. So the question was, are there more than two atoms? So if the question is yes, then the next question is the molecule symmetrical? Is there symmetry? Is there symmetry in the molecule? So then the question, if we answer that question as yes, the molecule is symmetrical, then it's going to be a nonpolar molecule. And so again, here we have our CH4 molecule. And notice that we've got all of them are the same atom, and we have a tetrahedral structure. And so the polarity in these bonds would cancel each other out. The CH bond is pretty much non-polar bond anyway, so technically these bonds are not even polar. So without polar bonds, you can't be polar anyway. So that's number one thing. Are the bonds polar? Um, but if we assumed here that they are polar, then it would still be a non-polar molecule because of the symmetry. Here again, we have boron trifluoride, and again, they're all the same atom bonded, and so they're bonded to boron. We only have the 3 bonds, so this is going to be a trigonal planar molecule. The bonds, the polarity in the bonds, right? So the arrows, again, are pointing towards the fluorines, and these is going to be, each of these, the bond angle is going to be 120 degrees for all of them, and so they're spread out symmetrically, and so the polarity of the bonds are going to cancel each other out, and then therefore the molecule will be nonpolar. And so here you can see for this molecule, the difference between this one and this one is that you have a different atom. They're no longer the same atoms. One atom is different. Again, if you had the same atoms, then it would be nonpolar. But if you have one atom that's different, or 2 atoms that are different, or 3 atoms, like here we have different. So if you have 1 or 2 atoms that are different in your molecule, that destroys the symmetry, and so now you have polarity. So because this bond is more polar than these 3 bonds. So if we were to assume that these 3 bonds are polar, the polarity in this bond would be greater than the polarity in these bonds, and so you no longer have the cancellation going on because you've lost the symmetry in the molecule. Same with your NH3 that we saw last time. So if you can follow this flow chart, if you remember the questions to ask, right? Remember, are ions present? If yes, ionic compound. If no, then the next question, are there more than one? Are there more than 2 atoms? If yes, then the question is about symmetry. Does it have symmetry, yes or no? And then if they don't have more than 2 atoms, then the question is, are the both atoms the same? If yes, then nonpolar. If no, then polar. So I hope this is a helpful tool for you to use. If you enjoyed this video, if you learned something from this video, please like this video, subscribe to my channel, hit that notification bell up there so you can be notified by other videos I put out. Put a comment down in the comment section. Let me know what you think and if you have any questions. Thanks for joining me. Have a great day.